everyone, this is Sonia Giri and today I am going to cover up a topic related to artificial intelligence. My topic is best first search algorithm. It's an informed search algorithm. So before going to those search algorithm, let's see what's the definition of artificial intelligence in a simpler manner. Artificial intelligence is a software thinking intelligently or a computer controlled robot who thinks in a similar manner as the humans think. Let's see the search algorithm. There are two types of search algorithms. One is uninformed and another is informed search algorithms. Uninformed algorithms are known as blind search algorithms too because they see and go through all the possible states to look for an optimal solution, whereas informed search algorithms, they look for the best, or you can say the good solution or a good option at the moment, then proceed to find a optimal solution. Let's compare between uninformed and informed search algorithms. Best first search algorithm uses heuristic technique or heuristic method. Heuristic means something like mental shortcuts that allows people to solve problems. In other words, it's simply quickest way to solve any problem, hence known as heuristic technique. The informed search algorithm gives lesser time complexity, whereas the time complexity in uninformed search algorithm grows exponentially. There is a reason for that because DFS and BFFs of uninformed search algorithms, these are uninformed search algorithms, and they grow, the time complexity grows exponentially because they look for all the possibilities without thinking, without finding the best option, like the informed search algorithm do. Next, also, informed search algorithm always provide you with good solution but not the optimal solution as in uninformed search algorithm. This is a disadvantage of informed search algorithm, that is, in most of the cases they will give you good solutions, but that the good solution they provide is not the it's not an optimal solution for all cases. That's why even though in worst case scenarios both the search algorithms have same complexity values, but best and average cases the informed search algorithm provides better results. What is heuristic value? Heuristic function estimates how close a particular state is to the goal state. It is represented by Hn and it calculates the cost of an optimal path between the pair of states. For example, there is a method known as straight line distance through which you can find the Hn value of two nodes. For example, let's see how it works. For example, A has coordinates like x1, y1. Similarly, G has node as x2. G has coordinates as x2 and y2. Through straight line distance, with the help of this formula, x2 minus x1 whole square plus y2 minus y1 whole square. With this formula, we can easily find the Hn value of A to G. That is, A to G. We can find the Hn value with this formula. Similarly, C to G. If we know the coordinates of C and G, we can easily find the Hn value. The best first search algorithm is also known as greedy algorithm because this algorithm chooses the best possible state before finding the optimal solution or the good solution. Step 1, place the starting node into the open list. Notice there are two types of list they handle. One is open list and another is closed list. Closed list includes those nodes which they will not prefer to go on and check whether their Hn value is the shortest or the smallest or whatever. Like see step 2, if the open list is empty, stop and return failure. Step 3, remove the node n from the open list which has the lowest value of Hn and places it in the closed list. Let's not study this algorithm and see the example below. Here you can see we have S node as the starting node and G as the goal state. Here we have the Hn values of each. Like for example, node A to G is 12. The Hn value of A to G is 12. Similarly, B to G is 4, C to G is 7, D to G is 3, E to G is 8, F to G is 2, H to G is 4, I to G is 9, S to G is 13, S to G is 13. This is the HN value and not the cost. G to G is 0, which is goal state. Like if the starting node and the goal state is both are same, that means their HN value is 0, obviously. So let's see how we will solve this. So okay, we have starting node S and we have two branches A and B. A and B. We will form a closed two list. One is open list and closed list. Okay, so S to A, yeah, A to G is 12 HN value, and another node is B, and B to G is 4. So we will prefer this node and we will keep A node into the closed list. So from B we have E and F as an option. So before going to E and F, let's see their HN values. E to G is, in the list it is 8, and F to G is 2. Again, we will not prefer the higher HN value, we will prefer the smaller HN value, which is F, and also in closed list we will keep the node E. Then from F there are two possibilities, one is I and G. I has the HN value of 9 and G has the HN value of 0, so we will prefer G and not I, hence I will be in closed list, and the path from S to G will be this part. This part will be the optimal, oh sorry, not optimal but the good solution. Yes, from S to G we have a solution like S via B via F finally to G. It's an arrow actually. So yes, from S to B, then B to F, then F to G. This solution might not be the optimal solution, but this is the first and the good solution provided by the best search algorithm. This is how we find the best search algorithm with the help of HN value. Let's smoothly conclude this topic here. We found the solution path S to B to F, then to the goal state G. Here the worst case scenario, the time complexity and space complexity of worst case scenario for greedy best first search is given. Also there are two characteristics which shows the advantages and disadvantages of this best first search algorithm. Moving on, let's finish this video because you guys are getting really bored, so am I. Here a kind message to you all. Thank you very much. Also thanks for bearing this manual transition since this is my first video. Hope you do not judge me. Thank you.